We have several different types of relays available. Some of them have 3 pins, but most commonly used relays are the ones with 2 pins. Additionally, some relays come sealed, meaning they are completely enclosed, and they have 6 pins at the bottom. Another type of relay has 2 poles on top and 4 pins at the bottom. The relay shown earlier also had 4 pins, and this one seems to have 4 pins as well. Besides these, there are some other types of relays, but they are not used as frequently. I'm just showing them to you so that you know such relays also exist. Some of them operate at 220 volts, while others work at 12 volts, meaning they can be used with different voltage levels. Apart from that, this is also a magnetic relay. Although it is technically called a magnetic contactor, it functions in the same way as a relay. To understand these relays, I will first talk about the inverter mini-split air conditioner circuit boards. DC inverters are categorized into 2 types. First category. In this type, the indoor unit does not have any relay. It receives direct electricity and has its own filtering system. The relay is installed in the outdoor PCB. The power supply first goes to the outdoor unit and then is sent to the indoor unit. So in this type of unit, relays are not used in the indoor unit. Second category. In this type, a switching relay is installed in the indoor unit. There is also a relay in the outdoor unit. The power supply first goes to the indoor unit and then is sent to the outdoor unit. Now, we will also understand the logic behind why one unit has only 1 relay, while the other unit has 2 relays. Now, when we look at DC inverters and non-DC inverters, the 4-pin relays are commonly used in both types, regardless of their shape. The shape of the relay doesn't matter. What matters is its function and how it is wired in the circuit. Now, to understand relays in more detail, I have cut open a relay so that we can see its internal structure. Let's lift its cover and take a look inside. Even though relays come in different shapes, their purpose remains the same. Now, I will explain how it works. Let me zoom in a little. Notice the gap in the middle of the relay. These are 2 separate points. How the relay works. When I press this point, it moves and joins with the other contact. Now, look at this terminal. It comes straight down and connects to a pin at the bottom. The second terminal takes a curved path and connects to another terminal, which is also attached to a pin at the bottom. These pins act as a switch, similar to a normal electrical switch, but with one major difference. Inside the relay, there is a coil that creates a magnetic field. When we apply 12 volts or 24 volts to these 2 points, the coil gets activated and generates magnetism. If you look closely, you will see another gap inside. When I press the relay, the metal plate inside moves and attaches to another contact point. This causes the 2 separate points to connect, forming a series switch. As a result, electricity flows from one pin to the other, completing the circuit. This is how a relay works and switches electrical connections using magnetism. Now, to test a relay, you have multiple options. You can check it while it's still on the circuit board. You can remove it and test it separately. You can check its operation by supplying electricity. And you can also test the relay without supplying power to it. If you look at the back side of the relay, you will see a printed internal diagram that shows how the relay functions. The 2 marked points represent the coil terminals. The other part of the diagram shows the switching mechanism, similar to what I demonstrated earlier. There is a single point that serves as the common terminal in the relay. You can choose any side as the common connection, depending on how the relay is used in the circuit. This means that by understanding the diagram and testing these points, you can verify whether the relay is working properly or not. In my videos, I often say that a relay becomes faulty. There are 2 main reasons why a relay stops working. If the coil inside the relay burns out or gets damaged, the relay will not work. This happens because the magnetic field is no longer generated. Without magnetism, the relay cannot switch contacts, meaning it will stop functioning. The gap between the switching contacts can accumulate carbon deposits over time. This makes the contacts turn black due to oxidation and arcing. When carbon builds up, the induction effect between the contacts is lost. As a result, there is no continuity, and the relay fails to pass electricity. If the coil is faulty, the relay must be replaced. If the contacts are carbonized, sometimes they can be cleaned, but in most cases, replacing the relay is the best solution. Now, let's proceed to test the relay to confirm if it's working properly or if it needs to be replaced. When we check the relay's coil resistance, it shows 157 ohms, which means the coil is perfectly fine and has no issues. Every relay has a normally open NO point and a normally closed NC point. All the relays of this type that are mounted on the circuit board are NO, normally open. They should not have any kind of continuity. If continuity is detected without power, it means the relay is faulty and the system has become direct, permanently connected. In such a case, the relay should not be used and must be replaced. Now, when you apply voltage to the coil and check the contact points, you should see continuity. This means that when activated, the relay should show some resistance, ohms reading, and produce a buzzer sound on the multimeter. When I press the relay manually, I can hear the sound, which confirms the switching action. But the proper way to test it is by applying power to the coil and measuring continuity between the contact points. If the relay passes both coil and contact tests, it is working fine. Otherwise, it should be replaced. Now let's talk about the logic behind this system. As I previously explained, DC inverter air conditioners are categorized into two types. In some models, there is no relay in the indoor unit, and the reason for this is that the main power supply comes from the outdoor unit. The power is first supplied to the outdoor unit and then sent to the indoor unit. I have observed that different brands use different techniques for this setup. When the power is routed through the outdoor unit, the load is shifted to the outdoor PCB, keeping it as close as possible to the power source. This design helps in two ways. First, it prevents power loss, and second, it reduces the chances of faults. Additionally, when the power is transferred from the outdoor unit to the indoor unit, manufacturers incorporate safety features to protect the system. Some brands use a filtering system to ensure clean and stable electricity reaches the indoor PCB. In these units, the power supply passes through safety mechanisms, including two fuses installed on the circuit. These fuses are designed to blow in case of a fault, preventing damage to the indoor PCB. To ensure proper installation and functionality, it is always recommended to follow the wiring diagram provided by the manufacturer, as this makes the installation process easier and safer. The relay is used in the system to ensure that the microcontroller has maximum control over the unit. Even if we bypass the relay and connect the circuit directly, for example, by using a jumper, the inverter unit will still function perfectly. However, the problem arises when a fault occurs. If the system is directly wired without a relay, the microcontroller will have no control over it. And in case of a fault, multiple components on the PCB could burn out or become damaged. This is why relays are used, to shift the load safely and to protect the PCB. However, the microcontroller does not directly control the relay. Instead, it uses a ULN 2003 IC as an intermediate driver. The working process is as follows. The microcontroller sends a signal to the ULN 2003 IC. The ULN 2003 IC then activates the relay. This allows the relay to switch the load safely, ensuring the system functions properly. Along with the relay, there is also a PTC sensor installed in the system. The PTC, positive temperature coefficient sensor, is capable of conducting electricity, but its capacity is limited. If too much voltage passes through it, its resistance increases, causing it to cut off the circuit to prevent overheating. What happens if the relay fails? Even if the relay fails, the unit may still attempt to operate. The system will try to switch on and function, but since the relay is damaged, its contacts won't fully connect. In such a case, electricity will pass only through the PTC sensor, which cannot handle high loads. As a result, the PTC sensor will work for a short time and then shut off, preventing excessive current flow. This is why the relay is necessary, to handle the load properly and prevent the PTC sensor from being overloaded. Additionally, keeping the relay in the circuit ensures that maximum control remains with the microcontroller. If the relay is not functioning properly, high-side components on the PCB, such as MOSFETs, IGBTs, or voltage regulators, can get damaged, leading to a complete PCB failure. Therefore, using a relay ensures safe operation, load management, and system protection. However, in some DC inverter air conditioners, there is a difference in the relay configuration. In this system, a relay is also installed in the indoor unit, unlike the previous type, where the relay was only in the outdoor unit. This setup is used in units where the power supply goes from the indoor unit to the outdoor unit, instead of the other way around. Just like in the outdoor unit, this relay is used to shift the load effectively. It provides an additional layer of protection to prevent electrical faults. These relays are designed to handle 25 to 30 amperes of current, making them strong enough to manage the unit's load. Since the relay in the indoor unit offers maximum protection, it ensures that any fault or overcurrent situation is handled before reaching the outdoor unit. This configuration helps maintain system stability and reduces the risk of damage to outdoor components. When it comes to non-DC inverter air conditioners, they are equipped with relays, and it is essential to have them for proper operation. Let me clarify why. In non-DC inverter systems, you cannot operate the unit without a relay. If the load is not shifted using a relay and the connections are made directly, the outdoor unit will turn on immediately, and the compressor will keep running continuously without any control. Therefore, having a relay is necessary to manage and control the system. Additionally, there are two types of systems in non-DC inverters. In one type, the the power supply goes from the indoor unit to the outdoor unit, where the indoor relay controls and powers the outdoor unit directly. In the other type, the power supply is already available at the outdoor unit, and in this case, a magnetic contactor is used in the outdoor unit. This magnetic contactor is connected directly to the main power supply, while only a light load passes through the relay. The relay's function is to simply switch the line and complete the circuit with the neutral line, which then activates the contactor. Once the contactor is energized, it powers the compressor, allowing it to start and operate efficiently. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.